Welcome to KUTV ELIMU Live. This is secondary mathematics, and I'm your teacher, Mr. Ndenga Elfas. Today, we are discussing Form 4, a topic we call differentiation. So we have Form 4 mathematics, and our topic today, is differentiation. Differentiation is one of the topics we teach in Form 4 mathematics, but for today we are going to discuss two specific areas. Our concern today will be based on the subtopics. One will be determining, we will have to get the gradient, determining the gradient of a curve at a point. We will study determination of gradient of a curve at a point. Number two, we will focus our lesson on determining the equation of the tangent, and the normal, to the curve, equation of the tangent and the normal to the curve. Therefore, by the end of our today's lesson, we should have looked at the two areas: determination of gradient of a curve at a point and the determination of the equation of a curve, or the equation of the tangent and the normal to the curve. To start us off, students, I hope we all recall what was covered in the introduction part of the topic differentiation, where you discussed the general principle of differentiating polynomials. And that is what we shall review first before we look at our two areas. So we shall make a recap of what we learned last time. And we said that you are given a polynomial y is equals to ax power n, or a function of any curve. Y is equals to ax power n, and the derivative is denoted by the dy dx. The derivative of the function will be denoted by dy dx. In this case, we said that when we are differentiating polynomials, what we do is that we take the power, multiply by the coefficient. That will give us a n. Then x retains the position, and subtract 1 from the power. We subtract 1 from the power. Therefore, the derivative of the function y is equals to ax power n gives us the dy dx, which is an x power n less 1. That is the general principle of differentiating polynomials. Y is equals to ax power n. Again, we held a position that if you are given constants, their derivative is always 0. If you differentiate constants, their derivative dy dx will always give you a 0. Therefore, if I was to give a function, for example, if I was to give a function of this kind, we have been given the function, you are told to determine the dy dx. For the function y equal to 2x power 3 plus 3. Y is equal to 2x power 3 plus 3. We determine the dy dx for the function y is equals to 2x cubed power 3. So what do we need to do in this case, students? Y is 2x cubed plus 3. Yes, the first thing that we shall do is we shall write our dy dx being the derivative is equal to, we take the power 3 multiplied by the coefficient 2. So we'll have 2 times 3 and then retain the x and less 1 from the power. So we'll have 3 less 1. 3 less 1. And for this case where we have 3 is a constant. The derivative of constants is 0. Therefore, it's like saying plus 0, which will not have any effect in this case. Therefore, what is the dy dx, students? Dy dx equal to 2 times 3 is 6x power 2. 6x power 2. Therefore, the dy dx of the function y is equal to 2x cubed plus 3 is 6x squared. Is 6x squared. So that is how we differentiate polynomials. Again, students, if we were to have this equation, this function, if we were to have the function as question number 2, we are told the function of a curve is y equal to 4x power 2 minus 3x plus 10. And then you're told to find the dy dx. Find the dy dx. That the function of the curve is y equal to 4x squared minus 3x plus 10. Find the dy dx. So what will be the procedure, students? Y dx, dy dx will be dy dx, which is the derivative of this function, will be, we take the power 2 times the coefficient 4. So we have 4 times 2, and then retain the x, and less 1 from the power 2. So we have 2 less 1. And then minus, in this case, this is 3x power 1. So it will be 3 multiplied by the power 1, and then x power 1 less 1. And we are saying for the constant 10, the derivative is 0. So we shall end up having dy dx equal to 4 times 2 is 8, x, then 2 less 1 is 1, minus 3 times 1 is 3, x, 1 less 1 is 0. And what is x power 0, students? Yes, x power 0 is 1, because any number power 0 is 1. Therefore, the dy dx equal to 8x plus 8x minus 3. 8x minus 3. That is the dy dx for the function y is equals to 4x squared minus 3x plus 10. Those are the concepts that we discussed in the introduction to the topic differentiation, just to give you an understanding of what is done when you are carrying out differentiation. The procedure is simple. Take the power of x, multiply by the coefficient, and then subtract 1 from the power. That is how we differentiate polynomials, or how we find the derivative of the functions of curves. In the derivative of functions, we also have to realize when we are differentiating, we relate this concept to what is covered in Form 2 under the topic called Gradient and Equations of Straight Lines. in that case, you are told that gradient of a straight line, that is for straight lines, you are taught something that a gradient is equals to the change in y over the change in x. The change in y over the change in x. And the sign change in y was used as that. And this is what we bring in this concept when discussing gradients of the curve at a point. Unlike for straight lines, if this is a straight line, this is our straight line AB. For the straight line AB, let's say we have different points along this line. And so we have point C, point D, point E, point F, along the same straight lines. Therefore, if you are to determine the gradient, of these points, let's say A and C, if you compare A and C, you'll be able to get the gradient of the line AB, because C is still on the same straight line. If I was to bring in a comparison of point D and E as well, we will be able to get the gradient for the line AB. Why? Because D and E are on the same straight line. The same will happen if I use F and let's say with B. I will still get the same gradient. Why is it so? It's because this is a straight line, and a straight line has an equation y is equals to mx plus c. A straight line has the equation y is equals to mx plus c, where m is for the gradient. M is for the gradient. Therefore, it's a constant that is linear, meaning it is on the same straight line. Gradient does not change in this case. So what we ought to remember and take note of is that gradient does not change for any points on the same straight line, So that is what is covered in Form 2, the determination of gradients of lines, of points on the same straight lines. And we are saying that it is important to remember that the gradient will remain the same. When we get to the differentiation aspect, we are not looking at straight lines. In this topic, we study curves. And with the curves, there is a different thing that happens when we are studying gradient of curves. Then you have to be able to identify and recall one thing, that if, for example, this is my curve, and I will say this is my curve y is equals to ax power n. That's my curve y is equals to ax power n. It will be clear that if I was to label these points, let's say point A, point B, point C, point D, point E, point F, point G, all the way up to point H. As the curve turns, there are different points that are noted. If we are to identify, for example, the coordinates of A will be the different coordinate for B, for C, for D, E, F, G, and H, because the curve turns differently. Therefore, you cannot be able to give a clear figure that represents the graph, the gradient of this curve at once, unlike for the straight line. So therefore, what do we need to do? That is what we want to discuss in our lesson today. How do we determine gradient of curves? one thing that you shall have to do is we have to specify the point at which we are determining the gradient. If, for instance, it's at point A, then it has to be specifically the gradient of this curve at point A, where we can easily draw a straight line, or we can draw a tangent at that point. We'll be able to draw maybe another line at this point and use this to determine the gradient at point C. Equally, we can do the same to point F. Use F to determine the gradient of the curve, and we draw the line at F. And so this is what happens with the curves, that you have to be able to draw a line at the given point. Students, therefore, it's clear that there is no one gradient that defines any particular curve. So you will be required to find the gradient not as for the whole curve, but to define a particular point. So what is the procedure then? If you're given the curve to determine the gradient of the curve, what will this be? So given the curve, y equal to ax power n, then we are saying gradient of the curve is determined as follows. So how do we determine the gradient of the curve at the point? Number one, we shall have to determine the derivative dy dx, i.e. gradient function, the gradient function. Therefore, the first thing that we shall need to do is to determine the gradient function. What is the gradient function of the curve? And the gradient function is determined by dy dx. Number two, at the given point, identify the value of x, and substitute the value of x, or this value, and substitute this value in the gradient function, Therefore, step number 2 will be determine the value of x at the given point and substitute it in the gradient function to obtain now the gradient. This gives the gradient of the curve. This gives the gradient of the curve at the given point. This will give the gradient of the curve at the given point. So that is what we shall be doing in the determination of gradient of the curve at a point. Gradient of the curve at a point. So students, let's therefore discuss this procedure using this example. We'll discuss this procedure using the example. Number 1, you're told to determine the gradient of the curve y is equals to 3x power 4 plus 2x cubed less 7x at the point 1, 4. At the point 1, 4. We determine the gradient of the curve y is equal to 3x power 4 plus 2x cubed less 7x at the point 1, 4. Therefore, anytime you see such kind of a function, which is not a straight line function, then be able to get the dy dx. The dy dx will give what we call the gradient function. So how will it be? This is how we'll work it out. We'll say our gradient function equal to the dy dx, equal to the dy dx, which will be, we take 4 by 3, 12x, then less 1 from 4. 4 less 1 is 3, plus, take 2 times 3, that gives us 6x, then less 1 from 3 to get 2, less 7. Less 7. That is step 1. Determine the derivative, the dy dx, or the gradient function. Now, what is the given point? 1, 4. So at the point 1, 4, what is the value of x? X equal to 1 and y is 4. So our concern is x. Therefore, what will be the gradient? Our gradient will be, take the gradient function and replace x as 1. That will mean 12 into 1 power 3 plus 6 into 1 power 2 less 7. Students, what is 1 power 3? That's 1 times 12. This is 12. Add 1 power 2 is 1 by 6, 6 less 7, and the answer is 11. Therefore, the gradient of the curve y is equals to 3x power 4 plus 2x cubed minus 7x at the point 1, 4 is 11, because it can change depending with the point that you are making reference to. That is question number 1. We've determined the gradient of the curve y equal to 3x power 4 plus 2x cubed less 7x at the point 1, 4. What if this is the second situation that we have? We are told we find the gradient of the curve. Find the gradient of the curve. Y is equals to 1 over 2 x power 4 plus 2x cubed minus 3x plus 6 at the point 2, 1. Find the gradient of the curve y is equals to 1 over 2x power 4 plus 2x cubed less 3x plus 6 at the point 2, 1. With the given example, students, can you be able to work it out? Yes. So let's be guided together. We are working out the gradient of the curve y is equals to 1 over 2, y equal to 1 over 2x power 4 plus 2x cubed minus 3x plus 6. And the first step that we are supposed to take is to find the dy dx, which is the gradient function. Students, what the dy dx? Let's differentiate together. 4 by 1 over 2 gives us 2x. 4 less 1 gives us 3, plus 3 by 2 gives us 6x. 3 less 1 gives us 2, less 3, and the derivative of 6 is 0, because that is a constant. Therefore, with that as the gradient function, we are getting the gradient at the point 2, 1. So at the point 2, 1, what is the value of x? Yes, the value of x is 2. Therefore, what will be the gradient? Yes, the gradient will be, we replace the value of x as 2 in the gradient function to have 2 into 2 cubed, add 6 into 2 squared, less 3. Less 3. Students, what is 2 cubed? That is 8 times 2, 16. Plus, what is 2 squared? 4 times 6, 24. Then less 3. And what is 16 plus 24? 40. Less 3? 37. Therefore, the gradient of that curve at the point 21 is 37. Is 37. That is how we get the gradient of the curve at a point. The procedure is simple. Simply find the dy dx, and the dy dx gives what we call the gradient function. Then at the given point, be able to substitute the value of x in the gradient function to obtain the gradient of the curve at the said point. So let's do the last example and see what we've explained. Number 3, you are told to find the gradient. Find the gradient of the curve. Find the gradient of the curve. Y is equal to 5x power 3 minus 2x squared plus 4x less 2 at the point 0, negative 1. At the point 0, negative 1. We find the gradient of the curve y is equals to 5x cubed minus 2x squared plus 4x minus 2 at the point 0, negative 1. My students, let's try it on our own. Yes, so what will be the situation here? We find the dy dx. Good, so let's start. The dy dx equal to, what do? We take 3 multiplied by 5. That gives us 15x. What do we do to the power? Minus 1. So we have squared less. What happens to 2x squared? We take 2 times 2 to get 4. Then x power 2 less 1. That gives us, that will be 2 less 1 is 1. Then plus, what happens now for x? Have the derivative is 4. And the derivative of negative 2 is 0. Good. That is the dy dx, which we are also referring to as the gradient function. The given point is 0, negative 1. Students, what is the value of x at that point? 0. So x is 0. Therefore, what's the gradient? Gradient will be, we replace x with 0 in this function. So we shall have 15 into 0 squared less 4 into 0. Then we add 4. And the result of all this will be 4 as our gradient. So that is how we determine the gradient of the curve at a point. Good. Our second item for discussion is the concept of determining the equation of lines. And not just any line, but we are determining the equation of what we call the tangents. Therefore, do we know what's a tangent as taught in Form 3? Yes, because in Form 3, under the topic circles, chords and tangents, you are given the description of what is a tangent. Therefore, what's a tangent, students? Yes, a tangent, when defining a tangent, A tangent is a straight line. Is a straight line. The straight line that is touching the curve at only one point. A tangent is a straight line that is touching the curve at only one point. What do we mean, students? If this is a curve, I can draw a tangent to the curve. I can draw a straight line. Let's say that this is a straight line. This is a straight line that is touching this curve at this point A. This straight line is what you are calling the tangent. We are calling this straight line the tangent. The point A defined by x, y. The point A is called the point of tangent C. This one is referred to as the point of tangent C. Point of tangent C. And this is our curve. This is our curve. Therefore, a curve with a tangent gives, or at a point of tangent C, can be used to determine the equation. And the description of a tangent as a straight line takes us back to Form 2, Topic 4, where we discuss equations of straight lines. That is why we have to be able to know what's a tangent and know that the tangent is a straight line. Therefore, the understanding of anything to do with the tangent has to reflect back to what equations of straight lines have to do. And that is why we said equations of straight lines have a general form of equations, and the equations are usually in the form y is equal to mx plus c. So therefore, students, what will we do in order to determine the equation of the tangent? Because we shall be given the curve and be asked to determine the equation of the tangent. What will be the procedure? This will be the procedure. So to determine the equation of the tangent, step number 1, you'll have to find the gradient function, that is dy dx. And number 2, you've determined the gradient, at the given point. Number 3, you use the given point and a general point xy. Why do we need to use the two? We need to use the two to determine the gradient expression and equate to the determined gradient and lastly you cross multiply and simplify to the form y equal to mx plus c. We cross multiply and simplify to the form y is equal to mx plus c. We simplify and we equate to the form y is equal to mx plus c. Therefore, we can be able to use this procedure as well to determine the following question. So our example, you're told to find the equation, find the equation of the tangent to the curve y is equals to 2x cubed plus 4x squared less 5x at the point 1, 3. At the point 1, 3. We determine the gradient, the equation of the tangent to the function or curve y is equals to 2x cubed plus 4x squared minus 5x at the point 1, 3. At the point 1, 3. What is the first step, students? Yes, we obtain the dy dx. So our solution, dy dx equal to, so let's differentiate. This will give us 6x squared plus 8x, then we minus 5. Good. At the point 1, 3, what is the value of x? X is 1. Good. X is 1. Therefore, what's the gradient? The gradient is 6 into 1 squared plus 8 into 1 less 5. Good. Therefore, this is 6 plus 8 is 14 less 5, it's 9. Therefore, the gradient is 9. Now, can you be able to get the equation of the line? Remember, it's a straight line. Yes. How do you get the equation of the straight line? We use the point 1, negative 3, that's positive 3, and xy. And xy, therefore, y less 3 over x less 1 equal to the gradient, which is 9 over 1. Then cross multiply. We cross multiply. Students, if we cross multiply, we'll end up with 1 into y less 3 equal to 9 into x less 1. So let's multiply this. 1 by 1 is y less 3. 9 by x is 9x less 9 by 1 is 9. Collect like terms. Minus 3 to the right side is plus. Therefore, y is equals to 9x. What is minus 9 plus 3? Minus 3. And that is the equation of the tangent. That is the equation of the tangent. Therefore, to get the equation of the tangent, you have to use the procedure that we've highlighted. First, you have to be able to give the gradient function. Use the gradient function. Use the gradient function. We use the gradient function. Sorry, this is minus 9 plus 3 gives us minus 6. Minus 9 plus 3 gives us minus 6. So we use the given gradient and the general point that is either given xy and the point at which you determine the gradient to find the gradient equation equal to the given gradient. You cross multiply and simplify. So our second and our last example will be to determine, we are asked to determine the equation of the tangent to the curve y is equals to 1 over 3 x power 6 plus 2x power 4 plus 2x power 4 at the point x equal to, at the point x equals to 0. Sorry, at the point x equals to 2. Sorry, at the point x equals to 2. We are determining the equation of the tangent to the curve y is equals to 1 over 3x power 6 plus 2x power 4 at the point x equal to 2. Different from question 1, we've been given only the value for x. Therefore, we shall have to get the value for y for us to be able to determine the equation of the line. But the first step is to differentiate dy dx. Before you work out anything else, differentiate. So we shall have a third by 6, that will give us 2x power 5 plus 2, that is 8x power 3. So when x is 3, x is 2, the gradient will be equal to 2 into 2 power 5 plus 8 into 2 power 3. 2 power 5 is 32 times 2 is 64 plus 2 power 3 is 8 times 8 is 64. Therefore, our gradient is 128. Our gradient is 128. Now, we go back to x is 2. When x is 2, what is y? Y is a third x power 6 plus 2x power 4. So we replace in the value of x as 2 so that we are able to obtain the value for y. So if we replace this, we shall have y will be equal to 1 over 3 into 2 power 6 plus 2 into 2 power 4. 2 power 6 is 64, so we have 64 over 3 plus 2 power 4 is 16 times 2, that is 32 over 1. So we sum this to have an LCM of 3, and 3 into 3 is 64 plus 3 times 32 is 96. If you add the two, 64 plus 96, that is 160 over 3. Now, students, what is 160 over 3? As a mixed fraction, we shall have 5, 15 into 10, that is 3, 1 over 3, or 53.3 as a decimal. Therefore, the point, our point is now defined by x is 2, y is 53 and a third. Then, how do you get the equation of the tangent? We use this point now. So we now use the point 2, 53 and a third, and a general point xy. So with this in mind, we shall have y less 53 and a third over x less 2, and we equate it to 128. 128 over 1. What do we do next? We cross multiply. So it is y less 53 and a third equal to 128x plus, less 256. 2 times 128 is 256. Then finally, what do we do? Take this to the right side, becomes plus, so y equal to 128x. Students, what is minus 256 plus 53 and a third? That is 256. We add 53 and a third, 53.3. So we have this 0. This will be 7. We are left with 5. 5 less 3 is 2. This is 0, and this is 2. Therefore, it is less 2 or 2.7. And that is the equation of our tangent. That is the equation of the tangent. Therefore, those are the areas that we want to discuss in our lesson today. We've discussed the general principle of differentiating polynomials. We have said if you want to differentiate, you have to multiply the power by the coefficient, and then you minus 1 from the power. And then number 2, we've been able to see how to get the gradient of the curve at a point by obtaining the dy dx or the gradient function, and at the given point use the value of x to replace in the gradient function that will give us the gradient. And number 3, we've been able to see how to find the equation of the tangent at the point, and we've defined the tangent as a straight line that touched the curve at only one point. And the procedure that we've given to determine the equation of the tangent is simple. First, you must have the gradient, which is obtained from the gradient function, and then the given point is used with the general point xy to get the gradient expression, which we equate to the gradient, cross multiply, and we simplify. So that is all for now. Until we meet next time, I've been your teacher, Mr. Ndenga Elfas. Thank you and goodbye.